Hello, hello. Are we live? Okay, it's working now. Welcome back to the advent of Syntran. Today is day 7. Before I get into day 7, I want to review a little bit of the things that I changed for day 6. So initially for day 6, I brute forced everything because it only takes 2 minutes to run. But there are other ways to do it, at least for part 1. So for part 1, you might notice that the motion is parabolic. If you hold the button for 0 seconds, you don't move. If you hold the button for the entire duration of the race, you don't move. But if you hold the button for like half of the duration of the race, you get a sweet spot where that's the optimal distance that you can cover by holding the button for exactly half of the race duration. So that's a parabolic curve. It's 0 for 0 seconds and 0 for the whole duration, and it's optimal halfway in between. And then if you remember the code that we had that like the distance that we cover is the speed times the duration. And then if you expand duration, it's race time minus j. We had this loop iterator j going from 1 up until 1 minus the race time. And then if you remember, the speed is also just the same as j, because if you hold the button down for 1 second, you move at 1 meter per second, or whatever the ridiculous units that they had were. So if you expand that, that's now j times race time minus j. Or if you distribute, before you distribute that, that's equal to the record distance. That's the intersection we're looking to find, because we want to know like exactly how long do we have to hold the button to tie the record distance. So that is equal. I think all of these should be equal, actually. So basically you have j times race time minus j equals the record distance. If you move that onto the left-hand side of this equals, it looks like this. So that j expression minus the record distance equals 0. If you expand that more, you get negative j squared plus race time times j minus the record distance equals 0. And now that's a quadratic formula that you can solve analytically. So in the usual quadratic formula, you have a times j squared. I don't know why I ended up using j. That's just the variable name that I picked. So now I stuck with it through this whole algebraic expansion. Plus b times j plus c equals 0. That's the quadratic formula. So in this case, a equals -1, because we have a negative j squared, b equals the race time, and then c equals the negative record distance. And then you can solve that using the quadratic formula. And you get 2 values of j, because there are 2 different button duration presses that will exactly tie the record distance. So that's j1 and j2, because the quadratic formula has this plus or minus. Yeah, and then we also want to know how many integer values of j are there between j1 and j2. So what you have to do is you have to get the min of j1 and j2 and then take the ceiling of that. You have to take the ceiling because we're only interested in integer solutions. We're not interested in some like 1.5 second button press or 1.5 millisecond, whatever the unit was, button presses. So you take the ceiling of that, and then you take the floor of the max of j1 and j2, because you don't really know whether j1 is going to be less than j2 or if they're going to be in the other order. So that's why we have to do the min and max. So that gives you the minimum integer number of milliseconds that you have to hold the button and the maximum number of milliseconds that you have to hold the button. And then the number of different milliseconds that you can win with is just j max minus j min plus 1, because this is a range that's inclusive of both bounds. So that's the easy way to solve part 1. Part 2 is tricky because you have to deal with a bigger number. What was the number? It was like... I did this in the last stream, but now I have to do it again. Let's get rid of all those spaces. So what is this number? It's like 597 trillion, and this has 15 decimal places. So you can't really represent that with a float 32. You need a float 64. And even then, you're going to get an approximate solution with a little bit of floating point rounding error. Syntran doesn't have 64-bit floats. Like, I do have 64-bit ints, and it's kind of shit. Like, they don't work in a lot of places where the 32-bit ints work. But I don't have 64-bit floats at all, so I can't really solve this accurately. I can solve this with like half of the precision because I have 32-bit floats. So you would have to do something else, like get an approximate solution with floats and then step by a few integers to get the exact integer solution. Or you could do like a bisection search or something like that. But I brute forced part 2, and that's the only way I can do it in Syntran for now. Maybe a bisection search could be implemented in Syntran right now, but I don't really have time to get bogged down in day 6 because now it's time for day 7. So let's get into that. Let's make a new directory for day 7. Let's look at the prompt and edit the input. I did change some stuff here. Okay. I just edited this algebra that I did in code comments right now. Those are the only uncommitted changes. So I got this quadratic formula solution for part 1 immediately after the stream last night. And I already committed that, so now we just have some comments. Let's look at day 7 and get the test input. I haven't even read this yet. We'll do that next. I should make like an automatic input downloader. I think some of the record holder people, they do that so that they can, you know, get straight into solving the puzzle without spending time clicking around in Google Chrome downloads like I am. It could save me like a few seconds each day and take me like 20 minutes to implement an automatic downloader. All right, so what the hell are we doing today? The hardest thing that I struggle with is I know I can skip like the first few paragraphs because it's just storytelling that has nothing to do with a puzzle. But eventually I have to start reading closely. I can't just skip it, and I don't know which paragraph I really have to start reading. So there's another thing I can waste time trying to optimize. Okay, we're playing poker. So I could have skipped all that. I did not need to read that. That has nothing to do with poker, and the poker is the puzzle apparently. T, Jack, Queen, King, Ace. So this is like a standard deck of cards, except we have a T card. Oh, T is 10. Yeah. Well, that's because it's a single character. They don't want to give you multi-character inputs, so that's why it's T instead of 10. Okay. Okay. This seems simple so far because we don't have suits. Like we don't have hearts, diamonds, jacks, and clubs, so we don't have to deal with. What do you even get with suits? Is that a flush? Yeah, I think you get a flush if you have everything the same suit, but we don't have suits, so we don't have to worry about flush, and we also don't have to worry about full house or royal flush. I'm not really a poker guy, so I don't remember all of the right poker terms. And you also don't have two of a kind and three of a kind. That's a full house, right? When you have two of a kind and three of a kind. Apparently, that's not something we have to deal with. Full house. Oh, full house. Oh, yeah. I completely ignored that. Thanks for pointing that out. Spontaneity. Spontaneity. I can't speak. But flush and royal flush, yeah, I don't have to worry about royal flush because there's, yeah, no, right, yeah, there's no suits. This is tricky because I don't actually understand poker scoring. A's are weak. It says A is the, oh, A is weak in like regular poker, but here they say A is the highest. I actually don't understand poker rules. So like the five of a kind beating four of a kind, I get that, but then like these, oh, they have conflicting information. Oh god, that's like day 2 or day 3 where I spent 10 minutes looking at a paragraph and I was like looking at 4 and I thought 4 was the right answer, but like there was some other number buried in the paragraph which was supposed to be the right answer. Oh Jesus. Because it's first card. Well, what do they mean by first card? Do they mean the one that you have 4 of? Or do they mean like the literal 3 is the first character here and 2 is the first character here? Yeah, I think they might actually mean 2 as the first card. Oh, okay, yeah. So now they're talking about the third card because the first 2 cards are the same. So when they say third card, they mean like the order of the cards in your hand matters, whereas in like real poker, you can shuffle your own hand around and it's still the same hand. But this is camel cards. This isn't poker. But it looks like they are reversing it. Uh, I think you just keep the cards the way that they're given to you, and you don't reorder the cards within a hand. All you have to do is sort every hand compared to the other hands. Okay, so now we also have bid amounts. Okay, so we have a rank. So this is a 1 pair, it is 2 3s. This is a 2 pair, it is 2 Ks and 2 7s. Oh, and this is also, the first cards both have the same label. Yeah, so when they say first card, they mean like literally the first character. The second card is K versus T. Yeah, so I don't think you're supposed to sort the cards within a hand. You just keep them in the order that it's given. Now we multiply the bid with the rank for every hand and then sum all of those things. Okay, this might take a while because we have to implement camel card rules or poker rules, quasi-poker rules. And like this stuff is not hard, I don't think, but the nuances of what you do when you have 2 5-of-a-kinds and then you have to like look at the individual cards, that this is what makes it difficult. No, you can do any language. I see a lot of people doing Python or JavaScript. I'm using my own programming language. It's called syntran. It's an interpreted language, and it's not very good. I recommend that nobody else uses it because when I find a bug, like I wrote the language, so I know that it's a bug and I understand the impact of it. But if anybody else tries to use my language, they're going to be screwed. Yeah. Okay, so I think I understand the prompt. Now I have to implement it, and this could take a while. Okay, so my template code, it just reads the input and echoes it back, so that is working. Now I have to sort these, and I have to keep a parallel array for the bid. Yeah. I have to sort. I think I'm just going to do like an n-squared sorting algorithm, because I don't have much stuff built into my language. The list is 1,000, so yeah, it shouldn't take too long to do like a bubble sort or whatever one of those primitive sorting algorithms is for an input of length 1,000. So the key is to have a comparison operation which compares 2 cards. And you don't have to, if you're looking at a list of 1,000, you don't have to like think of all 1,000 cards at a time. You just have to work with 2 cards and say, does this hand beat this other hand? So that's the key thing that we need to implement. All right. So first I actually want to count the lines so that I can pre-allocate a couple arrays. N is going to be the number of hands or the number of lines in my file. So we have 5 lines for the test input. And then we're going to allocate a vector of strings for the hands and a vector of integers for the bids. So let hands equals, they're all going to be empty strings to begin with, and there are n of them. And then bids, I really don't like that hands is 5 characters, but bids is 4 characters. Bids is going to be zeros, and there are n of them. Now we're going to read the file. We're going to split by space as a delimiter, and then the hand is going to be the left side of the space, and then the bid is the right side of the space, and we have to convert this string to an integer. The hands are already strings, so we don't need to convert anything for the hands. So we're going to have a vector of strings for the split of the current line. That's going to equal split string, split it by a space as a delimiter. And then hands, I need some kind of integer. This doesn't have to be a while loop. I know how many lines there are now, so I don't need to do a while loop. Some days, like, you can just read the file line by line and work that way. Other days, like, it makes more sense to count the number of lines first and then read the file and, like, process other things. So by default, I have, like, a while loop in my template, but sometimes it makes more sense to use a for loop. Because now I can use this iterator I to index the hands and the bids. Yeah, so hands equals string. It's the first part of the string. First part of the string vector after we split by spaces. And then the bids, we have to convert to an integer, so we have to use parse I32. And that's the second part of the string is after the delimiter. So I think that should do it for the parsing. That did not work. End of file. Well, how did I get to the end of the file? Is that 3.2? Let me edit this. Where am I? I'm hidden behind the chat. Okay, so we have the first line first. Oh, did I think I read too many times. So read line, and then we don't read line again at the end. So I had that twice in the loop. Because in the while loop, I have to read the line at the end of the loop to handle the end of the file correctly. Okay, there we go. Those are all the hands, and those are all the bids. Those look correct. Now we need a comparison function, which will take two hands and tell us which one wins. I don't know if we'll get this in the input. What if there are ties? Like, do I want to implement a greater than operator, or do I want to implement a greater than or equal operator? Let me look up bubble sort. The highest card wins. No, but like, what if every card in both hands is exactly the same? It probably doesn't happen in the inputs that they give us, but just in case, I'm wondering. Because then like you have something that's not really defined. Like, we want to know the rank. So if the rank is 1 through 5, if you have a tie, it's not going to be 1 through 5. It's going to be like 2, 2, 3, 4, 5 instead of 1, 2, 3, 4, 5. So I'm pretty sure ties can't happen. You'll never have two cards that are exactly the same. You're right. You might get like 2 full houses, and then you have to do the highest card. If they did that, they set you up for failure. Yeah. Oh, come on. Window management is hard. I just want to do a stupid sorting algorithm that's easy to implement, and I think that's bubble sort. Only 2 hands. Yeah, so you only need a greater than or equal operator or function, so you only have to compare 2 hands at a time, and then you can sort all of the hands with that comparison function. Yeah, this is n squared. You shouldn't use bubble sort in production, but this is advent of code. This is throwaway code that I'm never going to use again, so it doesn't really matter if it's slow. Yeah, you do like 1 versus 2, and then 3 versus 4. And this is kind of how the sorting algorithm works. Like you only compare two at a time. You compare the two that are in the red box, and then if they're in the wrong order, you flip them. And then you compare these two, and you flip them if they need to be flipped. I mean hands. Yeah. Yeah, so like this animation is sorting numbers, but it doesn't matter what the object in the box is, as long as it's some kind of object with a defined ordering. Integers have an ordering, and poker card hands have an ordering, so they can be sorted. Yeah, this is basically how you do bubble sort. You loop all the way through. Yeah, okay, yeah, it's a nested loop. So they have a loop here. I don't know what kind of pseudocode this is, but this repeat means loop. And then there's also an inner loop. So basically you have nested loops. And all we need to do is compare two things at a time and then swap them. So this pseudocode works for a list of sortable items. It doesn't matter if it's integers or hands or what. So that's what we're going to implement, but to do that we need a comparison operation. We need a function that takes two hands and tells us which one wins. So I think I want to do that manually with just like a couple cases from the test input. And we can follow along with the prompt. So this could be a good test case. They're both two pairs, and then we have to do some other logic to figure out which one of the two pair hands wins. So I think I'm going to compare these for my initial test. H1, hand 1. And we're not going to do the whole sorting algorithm yet. We're just going to see if we can compare these two hands. Is hand greater? Okay, this is the whole reason I looked this up. I wanted to know whether they use greater than or equals. So they use greater than here. That's the operator that I'm going to implement. Is hand greater than? So h1, h2. And we have to implement this function, and then once we have this function, sorting will be pretty easy. Function is hand greater than. We're going to have hand, I don't know, maybe here I'll call them A, and A is a string, and B is a string. So first we have to group them into these categories. And if we have like 5 of a kind versus 4 of a kind, we don't have to do any extra logic. So I think I have to look at this in my other monitor while I start working on this. So we're going to have a Boolean array. These are all 5 characters long. Every hand is 5 cards, so we're dealing with strings that are 5 characters long. So let's say let n equals 5. We're just going to assume that the strings are the right sizes. And if you try to call this with a string that's the wrong size, it's going to crash. And then we're going to iterate card by card. So like for this example, we're going to go, first we're going to look at 3 and we're going to say how many 3s are there? Well, there are 2 3s. And we're going to mark this so that we don't count the 3 again. And then we're going to look at the second card, which is 2, and say how many 2s are there? And there are no other 2s. So that will tell me how many of each card there are. Is this the right way to do it? I think this should work. All of the cards are unmarked initially, and then we're also going to have counts for each card. So the counts are initially 0, and then there's going to be at least 1 of the cards that are in the hand, and maybe more than 1. So we're going to loop. And we're going to have to do this for A and for B. So I might want to have another function that like, I might want to put this inside of an other function that like gives me the counts of each card. So let's just try to score A initially and see like how many of each card is there in A. So now we're going to loop again. And what do I need to loop to? So if we're at the first card, we're going to have to check the second card through N. So I think this inner loop doesn't have to go all the way through. It can go from I plus 1 through N. And then if card J matches card I, I'm going to increment the count. But that means I want to start at I, so I want each count to be at least 1, so I have to get to 1 by adding 0, and that means I have to compare I to I, so that has to be inside the loop. If card I matches card J, then we're going to increment the count. So counts I plus equals 1. Maybe I don't need this marked array. No, I do need the marked array. So does this work? And not marked. Because if I've already counted a card, then I don't want to mark it again. Is that right? This might not be right, but let's see what this does. This has to return a Boolean, and for now we're just going to return true. Okay. So we have two Ks. That part is right. We have two 7s. That part is right. But we're also double counting some things. So what I would like to have is 2 and 0. Because I don't want to double count the second K. So if a card has already been marked as matching another card, then I want to reset the counts, which I have now initialized to 1. I want to reset that 1 to 0. I think that might work. Nope. So why? Oh, I want to mark J. Okay, that's what I wanted. So we have two Ks. We don't do anything for the second K, so that's a 0. We have 1 6, we have two 7s, and then I don't count the second 7. So basically this is saying I have a 2 of a kind and another 2 of a kind, and then a lone card that's by itself, and the zeros mean nothing. So that's how I want to classify KK677. It's two of a kinds. Or two pair. It's called two pair. I don't know my poker terminology, so this is called two pair according to the puzzle prompt. And then I might need to sort this array. I think I'm just going to leave this array as is and then have some really stupid logic that looks if there are two 2s or a 2 and a 3 or a 4 or a 5, because we're only dealing with 5 cards. There are limited options to how many permutations of cards there are, and then how many different kinds of counts you can have. So I think I want a function that just gets the counts for a given hand. Get counts, and we're just going to cut the code that we just wrote and put it into this function. I think I still need n inside the other function, so I'm going to leave that there. And this goes in the other function now. So this is going to return a vector of integers. Yeah. So now we can get the counts for A and get the counts for B. So counts for A is just going to be CA. I'm going to be a little bit laconic here. get counts A and B. So I want to print A and print B. So B has 1K, it has 2 T's, and it has 2 J's. So 1K, 2 T's, and 2 J's. Now we can get the counts for a given hand. And the next thing to do is compare the counts of each hand. So we're going to compare, see that this has 2 pairs, and this also has 2 pairs, and then we're going to have to get into the extra logic. So, I think I need another helper function. So I need a helper function called count EQ. It's going to count how many elements of a vector are equal to a given value for integers. So it's going to take an integer of counts, and it's going to tell me, like if I call it with 2, it's going to tell me how many pairs there are. And then I can know whether I have a 2 pair or a 1 pair based on the return of this function. So count EQ, we're going to have a vector of I32s. This is how you denote a vector. And then we're going to have a value. Let's call it x. It's just a scalar, I32. And this is going to return a count of how many things are equal. So that's going to be another I32. This is going to be pretty quick. Let n equal 0. And then for I in 0 through the size of v, v is a vector, so it only has 1 rank, so we put that 0 there for the first rank. And then if vi equals x, we're going to increment n. So I think I'm going to need yet another function. So we have the counts, but now we want to do the count EQ. That's what this function does. It just counts how many things are equal. Now we're going to call the counts of A, see how many pairs there are. It's either going to be 1 pair or 2 pair or 0 pairs. And that's all you can have for a hand of poker. Does this work? Okay, so we have 2. That means there are 2 pairs in A. There are 2 Ks and there are 2 7s. In total, there are 2 pairs, so count CA2 is 2. If I call this count CA3, there should be 0. And if I call it 1, there should be 1. So let's verify that. 3, 2, 1. 3, 2, 1. And I'm expecting 0 triplets, 2 pairs, and 1 single. So 0, 2, 1. 0 to 1. That's exactly what I expected. Now we can get the counts for each hand. Now I need another helper function. I don't know what to name these things. I'm going to call it getKind. So function getKind. This is going to take... I think it can just take the string. So it's going to take A, and then it's going to call getCounts, and then it's going to call getKind. So I guess getCounts didn't really need to be a function. It could have been inside of this thing all along. This is... It's going to return one of these. What I need is an enum. I need an enum that can be high card, 1 pair, 2 pair, 3 of a kind, full house, 4 of a kind, or 5 kind. But I don't have enums in syntran, so I'm going to have to roll my own enum. We can just make our enums global constants. Type. This is type, it's not kind. Yeah. So the puzzle calls these types, that they're not kinds, they're types. 5 of a kind is a type, and 4 of a kind is a type, and full house is a type. So I want to name my function getType, and we're going to have some global constants. And it doesn't really matter what numbers we assign these to. I'm going to start with the lowest, so I'm going to define these in the opposite order of the puzzle prompt, as long as they're ordered in some way. So let high card, that's going to be 0. 1 pair is 1. 2 pair is 2. Now, the name has nothing to do with this value because, like, full house is going to throw off the naming convention, which is not really a convention. It's just a coincidence for 1 pair and 2 pair. I'm going to call it a triplet instead of 3 of a kind, because 3 of a kind is just too long. Then we have full house. I really didn't want to have a variable name that was longer than high card, so we're speaking German now. This is going to be a quadruple. It's just going to be a quad. And then 5 of a kind, pent. And now the coincidence, pent is 6 and quad is 4, but this enum has to be ordered. So did I get all of these? Remember, these are in the opposite order, so we have high card, 1 pair, 2 pair, triplet, full house, quad, and pent. I think those are all of the types. This is basically an enum, but we don't have enums in syntran, so this is how I have to do enums in Fortran. Let me show you the syntran source code real quick. I have tokens, so I have to have like a classification of every kind of token and every kind of syntax element. I'm really using 1 enum for everything, even though you could have like 1 set of enums for tokens and another enum for like kinds of syntax elements. This is my enum, so like the include keyword and the hash token, these all have different enum values. This is how I have to work in Fortran because Fortran doesn't have enums, and this is also what I have to do in syntran. So that's okay. I don't think C has enums. C++ added enums, if I recall correctly, but C didn't have it, I don't think. So now we have to classify a hand into one of these types. and we can use this get counts helper function. I actually don't need to call it here. Almost 40 years since I last touched Fortran, and you have forgotten everything. This is not Fortran, this is syntran, but that other code I was showing was Fortran. They have structs in Fortran now, or as they call it, user-defined types. They might have added that in like Fortran 90 or something, so it's changed. It's not the same language it used to be. Yeah, what the hell do I want to do here? I don't know if I need n anymore. Good. Yeah, a lot of things have changed for the better. So we're gonna get the counts. And in here, we're just going to get the kinds when we're comparing two hands to each other. So in here, this will get the counts, and then if count EQ, how does this work? It takes counts. I have to scroll up. Counts takes, or count EQ takes the vector and then the scalar. So the vector and then the scalar, if there's a 5, it's going to be pent. Type equals pent. So we're going to initialize type to something just in case. We're going to start it as -1 because -1 is not one of my nums. So if there are 5 of anything, this is 5 of a kind, which I've named pent. I have to be careful about the order here. Should I make these else ifs? I think if I do it in the right order, then these don't have to be else ifs. But if there's 4 of a kind, there can't be anything else. The trouble is you have to make sure you distinguish 3 of a kind and a full house. So you don't want to classify your full houses as just being 3 of a kind because they're not the same thing. But for 5 and 4, we don't really have to worry about that. 4 is just a quad. And then I think first I have to check if there's 3. And if there's just 3, it's going to be 3 of a kind. So that's a triplet. Now, this is the tricky one. If there's a 3 and a 2, then this is a full house. Now, if I switch the order of these 2 lines, that would be wrong. So if I did this, I would count a full house, but then this would also be true, so I would reset a full house to a triplet. So I don't want to do that. I want to have them in this order. Because if it's only a triplet, it will be a triplet, but if it's a full house, this will set it to a full house. And then I also have to be careful. With this same ordering, I have to do the same thing with 2 pairs versus 1 pair. Or no, I don't, because then I'm gonna compare it to 2. This is going to be the only time where I have a 2 on the right hand side of this double equals. So if there are 2, it's gonna be 2 pair. And if there's only 1, that's gonna be 1 pair. And if it's not any of these, Yeah, if it's not any of these, then it has to be high card. So what I want to do is I think I just want to initialize it to high card to begin with. And then if none of these conditions are met, it will still be a high card. I think that's it. Now we've classified the kinds, or is this, it's called get type, not get kind. Will this compile, or will it interpret? Wow, that actually parsed. So we have a 2 and a 2. And 2, according to my enum, first of all, I should have a comma in here. So KA, the kind of A, whoa, there's OBS. So the kind of A is 2, and the kind of B is also 2. And if we look at the enum, 2 means 2 pair. So both of these are 2 pairs. Apparently we've classified this correctly. I think I want to check that for every card in the test input now, while I'm thinking of it, to make sure that this get type function is correct. So, hand kind is going to be hands I, and then it's not called kind. Why do I keep saying K? TA and TB. So this is type, not kind. Get type of hands I. I have recursive IO. So I wanted to print just the hand and the type, but then when I call the get type function, it prints something inside of that function. So now I have this instead of just like the output of the function that I wanted. I think I also want a helper so that I can read this. So I want to type to string helper function. So then instead of like the value of the enum, I can see the name of the enum. And then get type cannot print anything anymore because that recursive IO is very confusing. And that's actually happening inside of get counts. Yeah, so this is the extra printing that I don't want. And then I want to translate this enum back to a string. So function type to string, it's going to take a type, which is actually an integer, because all of these are I32s, and it's going to return a string. And we're basically going to invert this. I'm going to copy and paste this 3 times. So yank, put, and now if I didn't need to paste it 3 times, just 1 less time would have been sufficient. So if t equals that, then str equals that. Don't ask about this line. I've explained this in previous videos. I'm really ashamed of it. Okay, I just need a comma to make this readable. So hand type. This is one pair apparently. This is a triplet. We have 3 5s. This is 2 pairs. We have 2 Ks and 2 7s. This is 2 pairs. We have 2 Ts and 2 Js. And this is a triplet. We have 3 Qs. They didn't give us any full houses in the test input, did they? So I think I want to run this on the real input to make sure that I can get like full houses and 5 of a kind, or a pent, or a quad as I'm calling them. So are these right? First of all, is the test input correct? So this, we have a 1 pair. We have, where's the triplet? Why did they not give us these in the same order? You have a 1 pair. You have 2 2 pairs. They both start with K. And then we have 2 triplets, T5 and QQQ. Okay, so I think all of those are right. Let me try this on the real input. First of all, I'm printing, oh, this is inside the loop. This is in the main loop. I want to hide this. Okay, so now I'm just basically pasting or printing the input hand and its type. So that's what I want to verify. Let me check out the real input real quick and run it on that. So I'm also printing all of the hands and all of the bids at the end. I'm going to spot check a few of these, at least quads and pence. First of all, yeah, there's a quad. This is a high card. We didn't have any high cards in the test input. Are there any pence and full houses? I have to redirect this. Okay, there is a pent. We got 5 Js. Are there any more pents? There's only 1 pent in the whole input, apparently. Maybe my code is wrong. I know we already saw quads. What about a full... There's no full house? There's no full house in my input. I don't know if that's right. Yeah, I could like manually test a full house if they didn't actually give me any full house. Yeah, before I do that, I need a refill on my drink, so I will be right back. I also have to feed my cat, so give me like 1 more minute. Okay, we're back. So I don't know if they gave us any full houses. I want to make sure that I can classify full houses correctly. It did give us this, so I can like manually test this string and these ones to see if I can get those correct. Let me just look at my code for a second because maybe I just have an obvious error. Whoa. So if we have a 3 of a kind, so that's count 3 equals 1, and a 2 of a kind, count 2 equals 1. Callie, it's my microphone. Callie, I'm streaming. Don't you want your dinner? There's dry food on the menu tonight. Callie doesn't really like it when I stream. She likes it when I give her attention, so she gets jealous when I give Twitch attention. Say hi to Twitch, Callie. Good girl. You guys hear that purring? So I think this code looks okay. Am I? Oh. I'm resetting it to 1 pair. Yeah, so I need to make a lot of these else ifs instead of just chaining them together like this and hoping that the order is correct. So what if I put 1 pair at the top? Because where else? Okay, now we've got a full house. Yeah, 3 3s and 2 9s. And here's another full house, 2 3s and 3 9s. That's the opposite of the last one we just looked at. 2 Qs and 3 3s. Do I have the other ones correct now? So do I still have 1 pair? Let me... Yeah, let me just look at my enums so that I can remember which enums I have. So do we have a high card? There are no matching cards in here, so I think this is a high card. Do we have a 1 pair? That looks like a 1 pair. Do we have a 2 pair? That looks like a 2 pair. Triplet. That looks like a triplet. We already looked at a couple full houses. Quad. Quad is there. And finally, pent. Yeah, I think this is okay. So that seems to work. I want to do the test input one more time and make sure that all of those are correct. Callie bumps my microphone. I have to point it back at my face. So we have a 1 pair, a triplet, 2 2 pairs, and another triplet. I'm pretty sure that was correct. Okay. Yeah, we have half of the comparison function. So now we have to break things that are almost a tie. Like if we have a 2 pair compared to another 2 pair, now we have to break the tie by comparing the first character. In this case, they're the same. And if the first character is the same, then we have to go to the second character. Yeah. and that's going to go into the isHandGT function. So first of all, if the types are different, we don't have to break any near ties. We can just return early. I don't know if return early is the right word because I don't have a return statement in syntran, so I can't return early. But yeah, if the types are different, that's what this function does. It just compares two hands. So if A is greater than B, we're good. But if TB is greater than TA, then GT is actually false. GE is going to be our return value, or GT is going to be our return value. If they're equal, then we have to break a near tie. Actually, don't need parentheses here. They're optional. You can put them there if you want to, but they don't have to be there. So I think it's better to remove them. So if we have a near tie, then we have to compare the first card, right? This is in the puzzle prompt. If two hands have the same type, a second ordering rule takes effect. Start by comparing the first card in each hand. If they're different, then the one with the strongest first card. If they're the same, then you have to keep going, potentially all the way up until the end of the deck. So this is like a lexicographical ordering. Strength. So we're going to need like a strength helper function to get the strength of an individual card. But we're going to have a while loop. Let I equal 0. And if the first card of each hand is the same, then we have to go to the second card. So I is going to keep track of which card we're comparing. And while the cards are the same, so while AI equals BI, we're going to compare the next card. That's all that loop has to do. So this is going to scan I until we get to a card that's different in hand A and hand B. I think I'm only going to have time for part 1 today. I think I can finish part 1. I don't know what's coming in part 2. Maybe it's difficult. Unless part 2 is really easy, I think I might run out of time tonight, because I don't really want to be streaming later than like 9 o'clock. So if this is the case, we're going to loop like that. And then I don't think there are really any shortcuts I can take. Like, because if these were alphabetical, you could do like some ASCII ordering hack where you just compare the ASCII values of these characters. But I don't even have a way to do that in syntran. So I need like a helper function anyway. So we're going to have strengths from low to high. And that's going to be another enum, sort of similar to our type enum, like 1 pair, 2 pairs, or quad, or pent. We're going to have an other enum that ranks the strengths of each of these things. So let me just copy that verbatim. And I might have to flip them in the other order. Yeah, 2 is the lowest, so I'm going to want to define these in the other order again. Type of hands enum. Now I want to have a strength enum for breaking. I don't want to call it a tiebreaker because like there won't be any ties. So this is going to break near ties. Let str, and I'm just going to name it after like the card. let me just paste in that stuff that I copied and then break this up into lines. Get rid of that or. So let me do a macro. Wait, let me escape. I'm not recording, am I? I think I have to see under my webcam. Oh. Okay, I'm good. Okay, now I have this window out in the open, and I have to put that back. Sorry. Here's what I was looking for. It says recording macro queue. So I don't want to start recording yet. Okay, now record a macro, find a comma, delete it, delete the space, enter a line break. Now we're going to replay that macro a bunch of times. And now that is nice and formatted. So we're going to say let str strength of whatever. What the hell is that? I don't know what that was. These are not all going to be 0, obviously. I want to have these in the opposite order, so strength of 2 is going to be 0. And then we're going to count up that way. If anybody has a quick way of doing this in Vim, just like reordering a column of integers, let me know, because I just like do this part manually. And then when I get to tens, I at least do that. And then I like to have my ones digits aligned. Yeah, because I do texting like that more often than you would think. So if there's like a way to do that very quickly in Vim, somebody please let me know. Okay, so now we have the strengths of all of these. I don't know, maybe I want to reverse the order of these lines, but I think I'll just leave it as is, because I think I've done that before in Vim, like reverse the ordering of a group of lines, but I have to Google it. I can't remember how to do it off the top of my head. Yeah, and now we need a helper function that gets the strength of a given card. So function get strength, and that's going to be basically a character or a card. I'm just going to call it C. It can stand for character or card, whichever you prefer. But I don't actually have a character type in syntran, so this is actually going to be a strength of length 1, and now this is going to return an integer strength, which is going to be one of these enums. And we're going to have a similar thing like this. So that's not what I wanted. God damn it. I hope that's enough lines. Okay, that worked. Let's indent that. If C equals something, then strength equals the enum. And we're going to fill in that other thing in a second. And I have trailing white space. I hate trailing white space. It's gone. There we go. Now I want to just column copy paste that. And there we go. There's our little helper function. And that's the return value. There's probably some better way to do this than all of that junk. Like you could define an array and then like invert the array, but this might actually be more efficient than like trying to search a whole array just to look up something from a table. And I don't have hash maps, so there's no way I can like put in a character and get out an integer unless I map the entire ASCII table. But again, I don't have a way of like converting ASCII characters to integers in syntran, so I just can't do that in this language. Now, we've scanned until there's a card that's different, and then GT is going to be strength. What is it? Get strength? It's called get strength. AI is greater than get strength BI. Okay, so we can print that higher up. Let's not even debug this. Let's assume that that works. And let's test it on the inputs. Before that, I think we'll need a sorting function. And then we'll just sort things and see if it's the right answer with a test input. Now we can get rid of this to-do note. We can just return the answer. All right. Yeah, let's do this one as a test case. So is this greater than this? It's saying true. Is this the one that wins? So K is the same. Is K stronger than T? I honestly can't remember. Which one of these wins? Both two pair. KK 6, 7 is stronger. K versus T. So I think we got that right. Let's compare these two because this is another tricky tie-breaking case. Is it tricky? I don't know. Let's just sort the inputs because here you could just do the first character. You don't have to iterate anything beyond the first character. Like an actual tricky edge case is this, where you have to go up to the third character before you break the tie. But I don't feel like making this a test case. I just want to sort the whole thing and see if I can get it right. So again, like I mentioned, I don't know, an hour and 20 minutes ago or something, I'm going to use bubble sort to sort all my cards. And then it's just going to use this comparison operation function that we just implemented. So what we're going to do is we're going to have an index array because we have to sort the hands, but we also want to keep track of the bids. So we don't actually want to change the ordering of hands. We just want to get an index array so that we can use the same index array with hands and bids. So we're going to make an index array. Let idx, for lack of a better variable name, equals 0 through n. Remember, n in this function is the number of lines in the input file. So the index array is just the identity index to begin with, and that's 0 through n. Now we're gonna call a bubble sort function. So I think I can actually bury this inside of my sorting function. So we're gonna let idx equals bubble sort hands. And now we can finally start to implement the sorting function. This is a vector of strings, and it's going to return a vector of integers. That's going to be the idx array. We're only going up to 1,000 in the real input, so this is fine as a 32-bit integer. And at the end, this is really terrible, actually. I said I'm ashamed of it. I'm doing this to suppress an implicit print, because if I just return like this, idx will get implicitly printed, and then I have a bunch of printed junk every time I call bubble sort. But if I assign it to something else, that suppresses the print. The problem with this is there's a copy. So I'm now copying this array into answer. And then I think the way I have syntran implemented, there's another copy out operation. So ans is then going to get copied to idx here when I call bubble sort. So like every time I call this function, there are now like two copy operations that are entirely redundant. Like I need to have a way of like passing things by reference in syntran. But right now, everything gets passed and returned by value. So there's a lot of extra copying that slows down stuff. But it's an interpreted language. What are you going to do? Efficiency is not the name of the game in interpreted languages. So we have to implement bubble sort now. Remember, this is bubble sort. N is the size of hands. Basically translating the pseudocode from Wikipedia into syntran. Okay, the Wikipedia says it's a zero-based array, so I can actually loop from 1 to n-1 inclusive. So if it's inclusive of n-1, I want to loop like that in syntran, because syntran is not inclusive of the upper bound. If hands, we're going to call it is greater than, is hand greater than, hands i-1, and we're going to compare that to hands I, then we swap these two things. First of all, let's do the easy part. You set swapped to true, and then you keep doing this outer loop until you don't have to swap any more bubbles. That's how bubble sort works. Yeah, so remember we're not changing the hands, so we don't actually want to swap the things that are in hands. We want to swap the index array, because then we keep the order of hands intact, but we have an index array that gives us the sorted order, and that way we can also sort the bids in the same order, so we keep the hands associated with the bids. If I had a struct, you wouldn't need to do this. You could like change the elements by grouping the hands and the bids together into a struct, and then you could sort the struct and not the hands. But I just have parallel arrays, so I have to use an index array. So that's going to be idx we need a temp. I'm not actually going to make a swap function. So let temp equals idx i-1, and then idx i-1 equals idx I, and then finally idx I equals temp. So now we've swapped idx i-1 and idx I. That might be it for bubble sort. I'm not going to optimize this at all. We only have to deal with a list of 1,000 cards, so this should be okay. I don't know what's coming in part 2. Maybe this will break down epically for part 2, but I might not have time to even attempt it. Okay, we're calling bubble sort, and then I want to print these in the sorted order. So to do that, we're going to iterate again, and we're just going to print hands idx I. And now when I subscript the hands array with the index array, this will print hands in the sorted order, if I did it right. That's a lot of ifs. So that looks like it might be right. I have to look at this. So 3 is the only one pair. KK6 is next, and then, yeah, they say KK6 is stronger than KTJ. And then finally T5 QQQ is stronger. Yeah, so this is correct. Yeah, we're basically there. Now what do we have to do? We have to give everything a rank. So that's going to be just the index plus 1, because I have 0-based arrays. These ranks start at 1, and it goes from 1 through 5 for the 5 inputs. So we just have to add 1. And then what do? We multiply the ranks by the bids and sum it all up. Yeah, I think I can do that. I think we're basically done with part 1. Unless there's something tricky in the real input that I haven't considered. But as far as the test input goes, the test input looks good. So I think sum is already initialized to 0. Now what do we have to sum up? We have to sum up the rank times the bid. So sum plus equals the rank is going to be I plus 1, because we have to convert to a 1-based index. And then we multiply that by the bid. And for the bid, we're going to use the same index array times bids idx I. I think that should do it. 6. No, it's 6440. It's so close. Did I do like the +1 thing correctly? How was I so close? Let's figure out what the hell is going on. It's 1 times 765. What? No, my comparison is wrong. I can't read this. So this one is first. Oh. K is stronger than T. All right, we have to dig into these tiebreakers. So we're comparing the right character. K versus T. Do I have the strengths in the right order? So 2 is the lowest. A is the highest. K versus T. Why is that not getting the tie broken correctly? Okay, K versus T, it says true. KK is stronger. Is my bubble sort wrong? Golly. Can't jump on my desk, okay? I'm sorry, Callie. Is this comparison function returning the right value? I don't know what I need to debug here. I thought all of the pieces looked good, but it's not coming together correctly. Because these two are in the wrong order. The rest is okay. This is the lowest hand, and this is the highest hand. And this tiebreak scenario, these are both triplets. This tiebreak scenario is broken correctly. So do we have a Q and a T tiebreak? Where? Oh, I'm going one. Am I? No. Yeah, because I want to, if they're the same, I want to add one more. So, but then why do I never tiebreak? I should tiebreak T versus Q at some point. Is K stronger than T? K is king, T is 10. So yeah. Ace, king, queen, JT. A is the highest card. A is the strongest. Does it never compare these? I think it... Okay, this is I minus 1, so that makes sense why we're starting at 1 and not 0. And then we reset swapped to false at the top of this every time. And then if we make it through a whole pass and we don't have to swap anything, that means the array is sorted. Is my swap correct? Temp is I minus 1 is I is TMP. I forgot to use the index array. So every time I index hands, I have to use another level of indirection and put the index array in here. That's like the one thing I forgot to modify from while copying and pasting the Wikipedia pseudocode. I have to put in my index array. I remembered to do it here. I'm swapping the index array instead of swapping the values of hands directly. 6632. Isn't that still wrong? Did I write this? Come on, man. 6440. It's still wrong. Yeah, these things are still in the wrong order, but the rest of the array of hands is good. These two are in the wrong order. It's like the one that I'm getting wrong is the one that I explicitly tested. H1, H2, H1, H2. Okay, so now we're getting the T versus Q tiebreaker. So that part is good. But while you're these two, it says K is stronger than T. So KK677 is greater than KTJJT. So that means this should get the lower rank. I think my bubble sort is still wrong. So do I compare these two in the bubble sort? Because this is not part of the bubble sort. This is like the one test case that I have before the bubble sort. No, they never get compared. So the bubble sort doesn't do enough comparison operations. It should do on the order of n squared. IDX. Okay, so this is where we start the bubble sort. So they both start with K. We only do 4 comparison operations. I don't think I'm initializing swapped correctly. So swapped gets set to false outside of the inner for loop. This is really embarrassing that I'm failing to implement bubble sort. Starting the bubble sort, then we have 1 comparison, 2, 3, 4. We only do 4 comparisons. That cannot be right. Let swapped equals false. I wanted to make sure I didn't have like a local block variable where like I redeclared another swapped. I don't think I did. It says end swapped and then it immediately finishes the loop. This while loops. Do I have a bug with while loops in syntran? Swapped is false. I said it again without using the let keyword. Because if I use let in here, it becomes a local variable within this block. But I'm not doing that. What the heck? You know what? We can unoptimize the bubble sort. Instead of a while loop, we can just not break early. So we can do for j, I don't think I'm using j anywhere in this function. No, I'm not. We can just repeat it that many times, and that should sort everything. Oh my god. So I have some kind of bug with while loops, unless I'm not understanding my own source code here. Unless I'm not understanding my own source code here, there's some sort of bug in the syntran interpreter where while loops don't work the way that they should. And now I don't need this variable because I'm just brute forcing the bubble sort. I don't know what's going on there. While. Here's the thing. Like, don't I have other while loops that work? See, this one has like an actual operation here, not just a variable, a Boolean variable. Are those the only while loops I have today? Yeah, I have other while loops in utils, like reading until the end of a file. Again, there's no variable here. But here's one where I have a Boolean variable, and I'm using this Boolean variable as the while condition. And this stuff works. Like, I've tested this through multiple days of advent of code. I've used this helper function a lot, and it works. But for some reason, bubble sort is not working with a while loop. I'm pretty sure there's a syntran bug. Anyway, we have the right answer for the test input now. It's 6440. I'll show you that again. 6440 is what we expect for the test input. So let's try this on the real input. It's going to take a little bit to sort and print. A lot of the time here is just spent printing because they're what's 1,000 squared? There are a million comparison operations here just to sort this array. If you have a sorting algorithm like merge sort or I don't know, what's another good sorting algorithm? Quick sort. Those are order n log n instead of n squared. But I don't have the time to implement those, and I don't think I can implement them efficiently in syntran anyway because I don't have a way to pass arrays by reference. I can only pass arrays by value and by copying them frequently. This is too much printing. And while that's running, let's leave some of these things in here. I should be able to comment this out safely. I'm gonna leave that in there too. Still running. Maybe I do need a faster sorting algorithm. But having all of those prints commented out should speed it up a little bit. So that just parsed the input. That's what all of that printing was. And it should be in bubble sort right now. Well, I've got some memory leaks. That's another thing with syntran. I think when arrays go out of scope in a function, they don't get deallocated. So every time like I compare two strings, those two strings are in memory forever. And when you call that function again, I think it can get duplicated. So yeah, that's a classic memory leak. And this might grind to a halt and then kill my stream. So I might be stuck. Callie, you can't be up here. Callie, what are you doing? Okay, my memory is about to max out. So if the stream freezes, I apologize. Hold steady. Hold steady. I'm gonna let this run for a while. I'll be back.